Good morning. Welcome to another episode of Chemistry on the Fly with Mr. F. Today we're going to talk about 3.40 and the Bohr model. Now we've talked about nuclide symbols, and this was great. It gives us a lot of information about the atom. It tells us the element, the atomic number, the number of protons, the number of neutrons, the ionic charge, and the number of electrons. But one of the things that it really doesn't do is tell us about what the structure of the atom looks like. Now here's our old friend, Mr. Boron. Okay, we know that the number of protons of boron is equal to 5. The number of neutrons is going to be equal to 6. That's 11 minus 5. And the number of electrons is going to also be equal to 5 because there's nothing in the top right corner which shows that it's a neutral atom. Now we also know that the number of the protons and the neutrons belong in the nucleus, and the electron cloud is where the electrons are. This hasn't always been the case. Back in the old days, we had a solid model, which a gentleman by the name of Democritus, he was a philosopher in Greece, and he basically thought, you know what, I think everything's made out of little particles. And nobody really questioned that. But there was a lot of people that thought that it was earth, wind, and fire, and water. But either way, Dalton decided in 1804 that Democritus had something going on, and he decided that everything also was made out of individual particles. Now, the next guy was named J.J. Thomson. Now, he thought that this solid particle had a positive blob of stuff, and then mixed in with that positive blob of stuff were these negative charges. And he ended up calling it the plum pudding model because that's what it looked like. It kind of looked like maybe rice pudding with raisins in it, where the rice pudding part was going to be the positive blob and the raisins would be these negative particles. Now, the empty space model, which presented itself in 1911, was by Rutherford. Now, what Rutherford did is he kind of came up with the idea of the nucleus. And how did he do that? Well, he started firing alpha particles through a gold foil. And most of the time, the alpha particles just went through. Every once in a while, though, some alpha particles would ricochet off and go in a different angle. Now that told him that there was something solid in the middle of the atom, and he called it the nucleus. A little bit later, in 1913, Niels Bohr came up with the idea that the electrons, those negative particles, were actually in rings, and they would look like this. So they would have different rings and we'll call them energy levels in a little bit. And what happened is these electrons would orbit just like the sun, or just like the planets orbit around the sun, they would orbit the nucleus. Now, this is what we're actually going to change the name of it. We're going to actually call this the Bohr model. Now, what happens if we add more stuff? Okay, what happens if we add yet more? Well, it turns out that we need to add another ring and then put more electrons on them. Then what happens if we add more? We have to add another ring and put even more electrons on them. And what happens if we go further? More electrons, more protons, neutrons, bigger atoms, more electrons. Another ring, yet another ring. Niels, you okay in there? It's all right. Just checking on you. So Niels Bohr decided that realized that there were 7 energy levels. And they start from the inside out. So the first energy level will have the least amount of energy, and then they would get more energy as you would go away from the nucleus of the atom. Now he also realized that each energy level could have a certain amount of electrons. So the first energy level could have 2 electrons, the second energy level would have 8, the third energy level would have 18, the fourth 32, the fifth 32, the sixth 18, and lastly the seventh would handle 8. Now, if you add up all of these numbers, you will actually get up to 118 total electrons. Now, that is an interesting number because that is exactly the same number of elements that we have on the periodic table. Is that right? That's right. All right, let's go back to our friend Mr. Boron. Okay, again, we know that boron has 5 protons, has 6 neutrons, and the electrons is 5. Okay, because this is a neutral atom. Now, I want you to pay attention to where boron's located on the periodic table. You'll notice that boron is on period 2, which means that that is also going to be the number of energy levels. Okay, so here's our 2 energy levels, and we start putting our electrons on the energy level. Just like we did before, we have 2 on the first energy level, and we have 3 on the second energy level. The second energy level can handle up to 8, but we only have 3 left over. 2 went on the first, and then we only had 5, so that means that the remaining 3 goes on the second energy level. Well, what happens if we go to a larger element like chlorine? So we're going to have more protons, more neutrons, and we'll also have more electrons. And we'll have 17 protons this time, 19 neutrons, and 17 electrons since it's neutral. Now, what this means is that I have chlorine on period 3, which means I'm then going to have 3 energy levels. There's 1, there's 2, and there is the third. And just like before, we put our 2 electrons on the first energy level. We put 8 on the second energy level. And then on the third energy level, we have 7 left over. So we're going to put 7 on the third energy level. Now, the third energy level can have 18, but it's always going to have just enough that we have. We always fill from the center outward. So I have 7 left over. Now, what happens when I make an ion out of chlorine? Now, chlorine is going to be a -1 charge when it's an ion. Now, what does that mean to us? It means that we have 1 more electron. So, instead of 17 electrons, we're going to have 18 electrons. And what happens to that extra electron? Well, it fills up that last energy level. So you can see on the bottom here that we added an 8th electron onto the last ring or last energy level of the chlorine atom. So that's what happens when we have an ion. We add 1 more electron as we would. Now, I don't want you to think that Bohr in 1913 was the last thing that ever happened with atoms. We've learned a huge amount since then. Now, one of the next big contributions was to actually give us the idea of the electron cloud. And this was by a guy named Schrödinger in 1926. He realized that instead of orbits, we actually have the electrons don't just go around nice easy circles, they actually go somewhere within a sphere. And you can see here, this is kind of a representation of it. Now this is a little bit not quite right because Schrödinger also realized that we can't predict exactly where electrons are going to be. They're going to be somewhere within this range, this shell of around the atom or the sphere. So the first energy level, just like we saw, they'll rotate within the first shell. The second energy level will then rotate within the outer shell. Again, these would be very unpredictable. Somewhere within that region is where the electrons would be. Now, Schrödinger wasn't the last person to come up with some ideas about about electrons and about atoms. There's a whole bunch more interesting things that have been figured out, but it's beyond the scope of this class. So we're really going to focus mostly on the Bohr model. Guess what? That's all I've got for today. So we're the last page of Chemistry on the Fly for today. And of course, this is Mr. F. And as always, have a great day.